In this problem, a person accidentally grasps the terminals of a power supply, which is a very dangerous thing to do. The resistance between the hands of the person is 11 kilo ohms. The power supply has an EMF of 13 kilovolts, and it also has an internal resistance of 2 kilo ohms. Now, the first question is, what is the current that passes through the person's body? Let's just apply Ohm's law. So let's say this is the current passing through the circuit. It's a one loop circuit, so just a single current passing through each element. Following Ohm's law, current equals potential difference across the person's hands divided by the person's resistance. So that potential difference is equal to the potential difference between points A and B, so that's VAB. And it's also equal to the potential difference between the terminals of the battery, right? So let's set up the equation for the battery as well, and then combine the two equations. Here's VAB expressed in terms of battery's properties. It's equal to the EMF of the battery minus the potential difference across the terminals of the battery's internal resistance. Let's combine the two equations and solve for current. Here I have combined the two equations by eliminating VAB, and then I did some algebra to isolate I. Now I did this in multiple steps, so if you're not sure how to do this algebra, you can take a look at these steps. Let's go ahead and plug in the numerical values. The current passing through the person's body is equal to 1 amps, which is a fairly large value actually. This could be really dangerous. Now let's calculate the power dissipated in the person's body. Here's a general formula for power for any circuit element. It's equal to voltage across the terminals of the circuit element times the current passing through the circuit element. So P equals V times I. Now, for a resistor, like the person, we can combine this with Ohm's law to come up with a formula that doesn't involve V. So we don't have to calculate V. We can calculate V if we wanted to, but we can actually just quickly calculate power using R and I. So let's go ahead and do that. Here's Ohm's law. V equals I times R for any resistor in a circuit. We combine the two equations and obtain an expression for power that does not involve V in it. So power equals R times I squared. Let's calculate this value numerically. We get 11 kilowatts for the power dissipated in the person's body. Now let's design a power supply that is safer than the one in this problem. We want the current to be no more than 1 milliamp. What must be the internal resistance for the power supply for that? Assuming again the resistance between the hands of the person is 11 kilo ohms, and the EMF of our power supply is still 13 kilovolts. As before, we set the potential difference across the terminals of the battery equal to the potential difference across the hands of the person. We eliminate VAB that way, and then we are looking for the internal resistance, so we isolate lowercase r from our equation. And here's the numerical result. The internal resistance of the power supply should be equal to 13 mega ohms. So mega is 10 to the 6th power. Note that for this power supply to be safe, its internal resistance has to be 3 orders of magnitude greater than the person's resistance. And when I say 3 orders of magnitude, that means 1,000 times greater, which is equal to 10 to the 3rd power, hence the expression 3 orders of magnitude.